Welcome to my channel once again. In our last topic, we treated stoichiometry and we gave some example. In today's topic, we are going to talk more on stoichiometry with a different example as well. So on the board, I have a question. We said one of them is in an experiment, 10 centimeter cube of ethene was burnt in 50 centimeter cube of oxygen. A, which gas was supplied in excess? So calculate the volume of the excess gas remaining at the end of the reaction. So we'll talk about 10 ml of the methane was burnt in 50 ml of what? Oxygen. So look at this equation. If we should have a very simple equation, we say first step in stoichiometry, the equation must be balanced. We say C2H4, so plus 3 mole of oxygen. Let's check whether this equation is balanced. C2 plus 2 mole of water. We said we have carbon here, we have hydrogen, we have oxygen. Must have carbon here, hydrogen, oxygen. We said carbon have what is known as, it has 2 here, hydrogen have 4, oxygen is 3 times 2 is 6. Here carbon is 2 here, hydrogen is 4, oxygen 2 here plus 2 is 4. So how can we do this? We said carbon here, carbon is 2, carbon is 2 here, our carbon is 1 here, carbon is 1, hydrogen 2 times 2 is 4, oxygen is 2 here, oxygen is 2 here, that is 4. So we are left with carbon. We have carbon that is what? That is 2 here. Oxygen is short of this. If I should add 2 here, I'm going to have 2 times 1. I'm going to have 2 carbon. 2 times 2, 4 plus this 2 here, I'm going to have 6 carbon. So by so doing, this is a balanced chemical equation. So from this, let's make reference to this equation. So whenever that comes to your mind, when any hydrocarbon bonds in air, it gives 2 products. Once 2 specific products, it gives carbon dioxide and water. So by so doing, if I should have a CH4 plus oxygen, it's going to give me C2 plus H2O. So you will not balance this equation. Most of the time, students are allowed to balance this combustion reaction equation on stoichiometric questions. So when any hydrocarbon bonds in oxygen, it gives us to carbon dioxide and water. So in this aspect, we say in this now we say 1 mole or 1 volume. Let's say since volume is used, let's use 1 volume. 1 volume of this requires 3 volume of oxygen. We say we're talking about oxygen, 3 volume of oxygen. Yeah. If we should say 10 centimeter cube of ethene is required, if I should have 10 here, 10 centimeter cube of this ethene, yeah, in our normal laboratory work, if 1 volume is 10 centimeter cube, yeah, I'll multiply 3 times 10, 3 times 10. So by multiplying, I'm having 30 centimeter cube of oxygen is required. So if peradventure we said in an experiment 10 centimeter cube of ethene was burnt in 50 centimeter of oxygen, so which gas was supplied in excess? So from this now, in this reaction, we only need 10 centimeter cube of ethene to react with 30 centimeter cube of ethene. From this reaction, we can infer that the amount of oxygen given to us, the oxygen is in excess. Is in excess because 50 centimeter was supplied. So that is to say, look at the equation, calculate the volume. Okay, they say, look at this, which gas was supplied in excess? We said oxygen is in excess because 50 was supplied rather 30 is needed for the chemical reaction. Say calculate the volume of the excess gas remaining. Since the excess gas, we said we have the volume that is given to us is 50 centimeter cube, and the volume needed is 30 centimeter cube. So the volume that is in excess is 20 centimeter cube. So if you should check this question, it looks so gigantic, but it's a very simple analogy we can use to explain this concept. Since we need 10 mol of ethane, so from the reaction, we said 3 mole of oxygen is needed. So if I need 10 mil here, since 3 times 10, it's going to give me 30 mil of oxygen that is required. So we are supplied with 50 mil, and we will notice that oxygen is in excess because what is supplied is 50 mil. We can subtract the 15 mil from the amount of the volume we needed for the reaction to take place. So the amount that is in excess is 20 centimeter cube. So let's move ahead as well. Let's move ahead. We can use a given chemical equation to know the relationship between the amount of the reactant that participated in a given calculation, in a given equation. Calculate the volume of carbon dioxide gas produced. So we are going to compare the mole. Here we are going to compare this, the methane, and as well the carbon what? The carbon dioxide. We said one volume of this gas produces two volume of CO2. If peradventure, if 10 mil, which is the 10 mil of ethane is used, 10 volume of ethane is used, it will produce how many? Produces, since the mole ratio here is 2, going to have, and each of these one volume is 10. I'm going to multiply 2 times 10. That is to give that the volume needed for the volume that is produced when 10 volume of ethane is used is 20 cm cube. So you can look at how structured this question is, but it just with the help of this equation, a well-balanced chemical equation, we can make our interpretation very easy. So let's talk more about let's get a question on mass